Nevada desert, May 14, 1964. Something impossible roared to life. Engineers behind 6-foot-thick concrete walls watched Tory-IIC, a 500,000-pound thrust nuclear ramjet, unleash hell for 5 minutes straight. Exhaust temperature, 2,500 degrees Fahrenheit. Radiation levels, lethal for miles. The sound, a continuous thunderclap that would have shattered windows 50 miles away. This wasn't a reactor built to contain radiation. It was designed to spew it. The men who built it called it the Flying Chernobyl. And it worked. Perfectly. Too perfectly. These concrete bones are all that remain of Project Pluto, America's attempt to build the ultimate doomsday weapon. A nuclear-powered cruise missile that could circle the Earth 4 times, drop hydrogen bombs across entire continents, and irradiate everything beneath it just by flying overhead. We built it. We tested it. And then, in an act that might have saved civilization, we buried it. January 1957. The Pentagon issued an impossible requirement. Build a cruise missile that flies at treetop level, 500 feet, at 3 times the speed of sound. And it needs to stay airborne for months without refueling. Chemical rockets burn out in minutes. Jet engines need tankers. But physicist Ted Merkel at Lawrence Radiation Laboratory had an idea so audacious it just might work. Project Pluto. Take a nuclear reactor and rip off all the shielding. Everything that makes it safe. Punch a hole straight through the middle. Ram air through at 2,000 miles per hour. The air hits exposed nuclear core, superheats to 2,500 degrees, and explodes out the back as thrust. You've built a nuclear ramjet, an atomic blowtorch, a reactor with wings. The physics are elegant and terrifying. No moving parts. Just raw nuclear fire turning cold air into thrust. The hotter it ran, the faster it flew. The faster it flew, the more air it consumed. The more air it consumed, the hotter it burned. A perfect feedback loop of destruction. The reactor core, 57 inches across, about the size of an oil drum. Inside, 600,000 ceramic fuel elements containing 60 kilograms of weapons-grade uranium. Power density, 10 megawatts per cubic foot. Operating specs, hot enough to melt steel. 500 feet altitude, below radar, below interception. Mach 3 speed, crossing America in 90 minutes. The truly horrifying part. The unshielded reactor would continuously spray radioactive particles into its exhaust. This wasn't a bug. It was a feature. Even without dropping bombs, just flying over territory would contaminate thousands of square miles. Merkel's motto for his creation, the hotter, the better. They weren't pushing boundaries. They were incinerating them. How do you test something that destroys everything it touches? In 1958, engineers needed to test-fire a nuclear ramjet that would irradiate everything within miles, generate Saturn V-level noise, and required 1 million pounds of compressed air per minute to simulate Mach 3 flight without killing everyone involved. The answer: build the most elaborate test facility in history. Location: Area 401, Jackass Flats, Nevada. The government purchased an entire aggregate mine just to supply concrete for bunkers 6 to 8 feet thick, bomb shelters designed to contain the uncontainable. The logistics defied belief. To simulate Mach 3 air intake, they needed 1 ton of air per second. They borrowed submarine testing compressors from Connecticut, shipped them 3,000 miles, and built storage from 25 miles of oil well casing. The hardest part: moving a lethally radioactive reactor after each test. Solution: an automated railroad. Remote-controlled ghost trains carrying portable Chernobyls across the desert. After tests, the reactor, too radioactive to approach for weeks, would cool on its rail car until robots could disassemble it piece by radioactive piece. May 14, 1961. First test. Tory-IIC sits on its platform. From bunkers 2 miles away, technicians flip switches. Compressed air screams through pipes. The reactor goes critical. For 5 seconds, humanity's first nuclear ramjet roars to life. Power: 46 megawatts. Exhaust: 1,900 degrees. Radiation detected 100 miles away. The desert sand turned to glass. Radiation instruments maxed out and failed. In 5 seconds, they'd proven you could fly on nuclear fire. But they needed 5 minutes. Eventually, 5 months. They built Tory-IIC, bigger, hotter, deadlier. The test infrastructure alone cost $1.2 million. The air system required 14 million heated steel balls. May 1964. Tory-IIC achieves the impossible. 292 seconds at full power. 500,000 pounds of thrust shaking the desert like an earthquake. The exhaust plume visible from Las Vegas, 65 miles away. In the control room, engineers watched in triumph and horror. They'd built something that worked exactly as designed. That was the problem. Let me paint you a picture of Project Pluto in action. What military planners called SLAM, the Supersonic Low-Altitude Missile. The weapon: a pilotless bomber 88 feet long, powered by nuclear fire, armed with up to 26 hydrogen bombs, each 600 times more powerful than Hiroshima. The mission profile reads like humanity's darkest nightmare launched from the continental US. Accelerate to Mach 3 in minutes, leaving a radioactive exhaust trail across America. Pentagon deemed this acceptable losses. At cruise altitude, 500 feet, terrain following radar takes over. Threading between mountains at 3 times the speed of sound. The sonic boom alone, 150 decibels, shatters windows, ruptures eardrums, levels structures for miles on either side. As SLAM enters enemy territory, it releases its thermonuclear payload: Moscow, Leningrad, Kiev, each bomb guided to within 1,500 feet, close enough for 10 megaton warheads. Here's where SLAM becomes truly apocalyptic. After dropping its bombs, it keeps flying. With its reactor still burning, SLAM would crisscross enemy territory for weeks, potentially months. Flying so low and fast no defense could touch it, the missile would irradiate farmland, poison water supplies, contaminate cities just by passing overhead. The exhaust, radioactive particles with a 30-year half-life, would render vast territories uninhabitable for generations. The mathematics of destruction. Operating range: 113,000 miles. Circling Earth 4.5 times. Radiation footprint: 2,000 square miles contaminated per hour of flight. Pentagon war planners had a specific use. SLAM would launch after the ICBMs. Its job wasn't first strike. It was to ensure nothing survived. While survivors emerged from bunkers thinking they'd survived nuclear war, SLAM would arrive like a radioactive angel of death, systematically destroying anything the ICBMs missed. Then wargamers realized something terrifying. SLAM was too effective. Unlike an ICBM, which could be recalled before launch, SLAM, once airborne, was unstoppable. No abort codes. No self-destruct. No way to turn off a flying nuclear reactor. Launch by accident, miscommunication, rogue commander. There was no calling it back. Worse, SLAM destabilized deterrence itself. The Soviets would have to assume any unidentified aircraft might be SLAM. They'd have seconds to decide whether to launch everything. One Pentagon analyst wrote, "SLAM doesn't preserve the peace. It guarantees the war." Summer 1964. Something unprecedented happened. The scientists who built the Doomsday machine began arguing for its destruction. Ted Merkel, who'd spent 7 years perfecting this atomic monster, stood before Congress and argued against his own creation. "Gentlemen," he said, "we have succeeded in building exactly what you asked for." That's the problem. The room fell silent. Merkel explained the cascade of moral complications. To reach the Soviet Union, SLAM would devastate NATO allies with sonic booms and radiation. We'd be attacking our friends to reach our enemies. But it went deeper. Other Pluto scientists began speaking up. They'd solved the engineering challenge, but created something that violated every principle of proportional response, every notion of limited war, every hope of human survival after nuclear exchange. Dr. Theodore Taylor, a project physicist, later recalled, "We'd sit in the cantina after successful tests, and instead of celebrating, we'd go quiet. Someone would ask, 'What have we done?' No one had an answer." Meanwhile, competing technologies were making SLAM obsolete. Minuteman ICBMs could hit Moscow in 30 minutes. SLAM would take hours. ICBMs were invisible until impact. SLAM announced itself with earthquake-level sonic booms. The Air Force was having second thoughts. General Curtis LeMay, hardly a dove, reviewed SLAM's capabilities and allegedly asked, "How do we stop it from killing everyone on Earth?" The answer: you don't. Then came the coup de grace. The 1963 Limited Test Ban Treaty prohibited atmospheric nuclear testing. You couldn't hide a SLAM test. The radiation plume would be detected globally. Testing SLAM would be an act of war. July 1st, 1964. Project Pluto was canceled. Cost: $260 million. $260 million. $260 million. $2.5 billion today. At its peak, 450 people worked on the project. They'd revolutionized materials science and pioneered still classified computer modeling. At the farewell dinner, Merkel handed out tie clips shaped like SLAM missiles and bottles of Pluto mineral water, a grim joke about radioactive contamination. His closing remarks haunted attendees. "We proved we could build it. Let's hope that's enough to ensure no one else tries." The Tory-IIC reactor sat in the Nevada desert until 1976. When finally disassembled, workers found something chilling. After years of exposure, the ceramic fuel elements were still intact. Pluto could have been resurrected at any time. And now, 60 years later, it has been. August 8, 2019, Nyonoksa, Russia. A floating platform explodes. 5 nuclear scientists die instantly. Radiation detectors spike across northern Europe. Russia claims liquid fuel rocket accident. But isotope analysis reveals the truth. An unshielded nuclear reactor experiencing catastrophic failure. Russia was testing the 9M730 Burevestnik, Storm Petrel, a nuclear-powered cruise missile Putin claims gives Russia invincible weapons. The leaked specifications read like Project Pluto's Ghost: nuclear ramjet, unlimited range, low-altitude flight. They're building SLAM again, but modern technology might actually make it work. Where 1960s engineers struggled with materials, we have ceramics that withstand 3,000 degrees. Where SLAM needed crude radar, modern missiles use AI navigation. Where Pluto required ground control, autonomous systems make targeting decisions without human input. Dr. James Acton of Carnegie Endowment. In 1964, we stopped because we could. In 2024, I'm not sure we would. The Nyonoksa accident revealed something else. Satellite imagery shows Russia built an automated recovery system, railway tracks to concrete bunkers, robotic handling equipment, radiation-hardened storage. It's Jackass Flats reborn. But they're not planning to cancel. China, Pentagon sources say, pursues similar technology. Hypersonic missiles with nuclear propulsion, orbital bombers that loiter for years, weapons that make SLAM look quaint. Project Pluto's classified portions remain sealed. Miniaturizing reactors, controlling criticality in supersonic airflow, materials that withstand nuclear heat indefinitely. Every major power wants these secrets. Former Los Alamos director Siegfried Hecker, one of few with clearance to review Pluto's archives. We didn't abandon this technology because it didn't work. We abandoned it because it worked too well. The question isn't whether someone will build it again. It's whether they'll have the wisdom to stop. In 2023, Putin claimed successful Burevestnik flight tests. U.S. intelligence cannot confirm, but Arctic radiation monitors tell their own story, sporadic spikes consistent with an unshielded reactor in flight. The ghost of Project Pluto isn't haunting us. It's flying again. Somewhere in the Nevada desert, concrete foundations stretch across alkali flats, all that remains of Site 401, where America built and tested the ultimate doomsday weapon. You can still find ceramic fuel elements, slightly radioactive, engineered to withstand conditions that would vaporize steel. These artifacts mark where human ingenuity collided with human wisdom. And wisdom barely won. Project Pluto transformed from Cold War ambition into something more important. Proof that we can step back from the abyss. That sometimes the most powerful act is choosing not to deploy what you've created. Ted Merkel called it the flying crowbar, capturing both its crude effectiveness and fundamental absurdity. But the real leverage came from scientists willing to sabotage their careers by speaking truth to power. From military planners who chose stability over advantage. From politicians who, for once, listened to warnings about tomorrow instead of threats about today. They buried Project Pluto. The Tory reactors were entombed in lead and concrete, shipped to disposal sites, erased from memory. For 30 years, the project remained classified at levels reserved for our most devastating secrets. Now, as new nations chase the nuclear ramjet dream, as Burevestnik rises from Pluto's ashes, we face the same choice. Build the weapon that could end everything, or find the wisdom to walk away. The ruins at Jackass Flats offer silent testimony, not to what we built, but to what we chose not to unleash. In a century marked by humanity's capacity for self-destruction, Project Pluto's cancellation may be our species' finest moment. The day we invented Doomsday and decided to uninvent it. The fact that this perfect killing machine remains buried beneath the Nevada desert isn't just history, it's hope. What do you think? Was canceling Project Pluto wisdom or weakness? And with nations again pursuing nuclear-powered weapons, have we learned SLAM's lessons, or are we doomed to repeat them? If you enjoyed this story, hit subscribe for more stories where history, technology, and human ambition collide. Thanks for watching.